said, I will record every session. Any questions concerning the syllabus? Anything we discussed last time? No. Good. Good. So today we're going to get deeper into the topic. So we talked already last time about descriptive statistics and inferential statistics. So basically, descriptive statistics organize. Yes.
Sorry, are these posted?
Yes, they should be on your module. Can you access it on the modules?
Yeah.
Yeah. So it's module 2. Yes, it's chapter 1 in the book. It's module 2 in our class syllabus. Again, I would like to recommend to create folders, and this would be the folder class 2 or module 2 or whatever you want to call it. It really makes sense, trust me. Yeah, you will believe me. At the end of the session, after 26 modules, you will believe me that it was a good decision to make folders. Okay, descriptive statistics: organize, summarize, and communicate data and the statistics in that data. So basically, it helps you to communicate numerical information from that data. And we will do the underlying descriptive measures and matrices that can be used to describe this data. And we will get to that with next class when we talk about frequency tables. Then we're going to talk about means and medians and the variability around these central tendency measures. And you will see that this is just the most effective tool to essentially communicate, how should I say, the nature and the characteristics of your data. And this is really what descriptive statistics is all about. And that includes also the visual display of data, where you basically use graphs to display the data and display the distribution of your data. And secondly, essentially, you're getting to inferential statistics, and inferential statistics is basically where you're using a sample, a subset of your population of interest to essentially observe dynamics and capture dynamics within that sample that you're meaning to extrapolate to your overall population. So you do a little study in a sample subset, which is possible to study because you can't study an entire population. You study that in that sample under the assumptions that that sample is representative for the overall population, and all the dynamics, changes in blood pressure, changes in mood, changes in behavior, whatever it is, will extrapolate to the overall population, and those insights and inferences that you draw from your small sample also apply to a larger population. So if lowering blood pressure with a blood pressure medication is good for patients in my study, this will be good for everybody in the population. That is kind of the idea. This is going to. So this being said, we have talked about samples and population. This is just a recap from last time. We have a population that is basically a collection of all possible members of a defined group. Emphasis on defined group, because the definition determines what that population or what population is comprised in your defined population. That can be the citizens of New York, the citizens within the US, citizens living in New York, or the citizens of the US. Could be of any size, and it's just a question of definition. Good. The sample is a subset of the population of interest, and it's a proportion of the population. And these sample results are used to estimate those of the population, which is essentially what we will be doing with hypothesis testing, where we're basically taking subsets of our population and we're comparing means, which is a mark of the central tendency, to that of the population. So this is, for example, hypothesis testing using set tests, which will be the first hypothesis test that we will do. All this being said, you have variables that you capture. So if you remember the Excel spreadsheet, we had columns, right? Traditionally, these columns are variables. So that can be age, can be gender, can be race, can be income, can be, you name it, blood pressure, cholesterol, everything that basically determines the characteristic of one individual or one individual record. If you have repeated measures of one individual, this will be called a variable. If you have repeated measures of an individual, like you remember from last time, that earning spreadsheet that I had from Nicole, Teresa, Sarah, and John, I believe, that is multiple observations for one individual, and this will become then a time series if it refers to a timeline over time. Otherwise, it's cross-sectional, where you just have one time point, and you basically have each record is one individual. So this being said, these variables can be discrete or can be continuous. And there's a difference between those two, because discrete variables can only take on specific values. If you, for example, you have predefined categories within your variable, and you say, I want the variable of, I don't know, biological sex, for example, you have male and female, right? If you take on a discrete variable that is race or ethnicity, can be, I don't know, Hispanic ethnicity would be yes Hispanic, no Hispanic. Race could be African American or white Caucasian. So it's basically you categorize it based on predefined categories within your variable. And then you assign to an individual entry in your data set, you assign one of these categories that applies to the individual. And then essentially, at the end of the day, you're going to sum them up and you do counts. And you count and you calculate proportions of your population. We will do that later today. No, tomorrow. No, on Monday. Monday, next class, we're going to do discretization of continuous variables. So basically, you have two forms of these discrete variables. You have nominal and ordinal variables. So what is a nominal variable? Nominal, as the name implies, it has a name, right? It comes from Latin, it has a name. That means it's predefined criteria. Hispanic ethnicity, not Hispanic ethnicity. Is a definition that is named in some shape or form. African American race versus white Caucasian race, defined name. It's a nominal variable. Ordinal variables are variables that do have some order in some shape or form. Household income, 0 to 50,000, 50 to 100,000, 100 to 150,000, 150,000 to 200,000. These are ordered categories which apply to each individual record. That essentially makes them ordinal. Then you have lastly, and this is essentially a majority of variable will be continuous. The difference between discrete, hopefully is clear now. We have categories that are either ordered or that are just names. Continuous are variables that you basically use in your general day of life, which is age, for example. Age, while everybody of us has an age, if we would put all of us in a spreadsheet, each of us would have an individual entry, and this would essentially distribute all over the place, right? Well, for you, less, I would be all over the place, but it basically, it can take every specific value. So this is a continuous variable. And these continuous variables can take different values and can be distinguished between interval and ratio. Take it in for now, accept it, interval and ratio. We will talk about this more in detail. The difference essentially, just quickly to allude on that, interval variables are equally spaced and they are going to minus infinity and they go to positive infinity. So it can be, for example, temperature. Although temperature have limits, as we know, but essentially they can take any values that can either be positive or negative. Ratio variables are variables that are also equally spaced, but they do have a meaningful zero. And maybe, so there I'm getting some skeptical looks. So that's why I'm going a little forward, because this is essentially my favorite example. And I think it's a little too late in the game. So we talked now about discrete and continuous variable. And this is by far one of the best examples I've ever heard to outline that. So when you think of cookies, you have a nominal variable, that would be the name of the cookie, right? I don't know, chocolate chip, oatmeal raisin, or whatever cookies you want. You have ordinal, that would be, my favorite is really the oatmeal raisin. So that's your favorite. Then I go to the next student, what's your favorite? So you rank it for each individual, right? Then you have interval, and that would be the temperature of the cookie. Can be negative if you put them in the freezer, can be positive if you heat them up. And then the ratio, meaningful zero. That means that zero has an inherent meaning, and this in that context of the cookies is how many cookies are left. That's how easy it is. Yes. The interval variable would be equally spaced and can take on positive and negative values, and the 0 is just one random value. Because 0 degrees depends on which temperature system you adhere. I tend to go to Celsius because that's what I grew up with, and that's the only variable I haven't yet incorporated in the US system. 0 would be basically the point where water freezes in a way, right? Although you have the anomaly of water, but that's a different conversation. But it basically it's where freezing point starts at 0. So you basically, it's just another value. And the distinction to ratio is that it could not go below 0. For the number of cookies that are left, you can't have negative cookies except for when you give cookie loans. So it's not possible, right? Yes, you go first. Ordinal would be the ranking within the system. So you give, for example, you say, okay, so rate this cookie on a scale from 1 to 10. So that value would basically then create an ordinal definition. So these are not independent, whereas the name of the cookie is totally independent. So there's oatmeal raisin and chocolate chip is like, it's just two different cookies. So it doesn't give any ranking. As soon as you have ranking involved, flag, quote, important for the quizzes. As soon as you have a ranking involved or some kind of order, always an ordinal variable. Yeah? What's your question?
And the other question, can you explain ratio there?
Ratio, meaningful 0.
So what does that mean?
Well, if you have no cookies left, this is a very meaningful insight, right? So you want to have a cookie. If you have none, then your ranking, your order, and the name of the cookie is absolutely meaningless. So the 0 is very meaningful because it renders the other variables or the other characteristics meaningless in a way.
So what if you have 10 cookies left?
Then it is a ratio variable. It's still a ratio variable. It's about the variable, right? Spreadsheet. Think of this as a spreadsheet. You have name, ranking, interval, and ratio variable, which would be temperature and cookies in the jar. So those would be the 4 variables, where the name is a nominal variable, the ranking is ordinal, the interval is the temperature in which you found that cookie in the cookie jar, and the ratio is how many are left. Yeah, make sense? All right. Any other questions? Yes, please.
So what would make something a meaningful 0?
If you basically have no cookie at hand, that's the most meaningful characterization of your cookie jar. If, for example, you have 10 cookie jars and you have 10 entries in your spreadsheet, cookie jar 1 contains the oatmeal raisin, contains your most favorite cookie. And they are heated up to a temperature of 20 degrees Celsius, and there are 10 in there. Makes it distinctly different to cookie 2, where there was a chocolate chip cookie in there, like back in the days, but now it's empty. That's kind of the idea. That's a simple way to look at it. Okay. All right. Any further questions? Otherwise, let's go back because we skipped some stuff in between. So I really need to put this slide earlier. So to get now essentially to data. So we want to look at data. So data is being collected. Data is being collected. You can collect data retrospectively, as we do, for example, in patient data. We have patients that come to their treatment. We collect their data. We're doing something with their data, and we're looking at their data. That's retrospective because it's in the past. It has happened already. Prospective would we were collecting data forward. So this is you actively collecting data. So to illustrate how data collection kind of looks like, we have here the so-called Stroop test as an example. So the Stroop test is a very interesting test that is being used in psychology to detect some certain psychological phenomena. And it's done as follows. So I will show you in the following 4 words. And, well, do I have a volunteer who wants to do it? Not all at once? Yes. All right, great. Okay. It's not a big deal. Don't worry, don't worry. So look, okay, so are you looking at the PowerPoint? No, don't look at you're spoiling. So I'm going to show you now 4 words and say each word as quickly as you can.
White, red, green, brown.
Good. Now I'm going to show you words and white, red, green, brown.
Yeah.
Okay. Oh, you look at it on the PowerPoint. This is terrible. Okay, now go 1 slide further, because now look at the following words that are coming on the next slide.
White, red, green, brown. So like,
Yeah, and now go on the next one, go on slide number 8, or no, slide number 9, and tell me the color of the font.
oh, of the font.
Yes.
Green, blue, red, brown. No,
Really?
purple.
And this is the thought process. So if you want to do it right, you got to slow down, because like you got to trick your brain. And this is how the brain works. And this is why I find psychology very fascinating, or another psychologist is fascinating, because your brain slips over what you have just read before. And that's the problem. You're associating the word, and you're being asked to say anything about that word, your brain is like snaps and like gives out what it read before. But you need to take a step back, and you need to look at the font. You need to activate a different center of your brain. You're activating that, and then you should give the response, which takes you longer time. So now, if you look at this, yeah, it seems that we have a hard time inhibiting that, yeah. And when you look now, and thank you for volunteering, appreciate it. If you look now at the spreadsheet that I have uploaded on Canvas, you're going to look at your first data set. And I hope you can see that. This is just so terrible. Okay. So congruent and incongruent here basically gives you, with congruent, the reaction time of an individual, a student who participated, another volunteer, where basically the color matched the word. That's congruent. And when you was supposed to state the color of the font with an unassociated incongruent word, this is incongruent. So now you have 24 students who did the same experiment. And you get 24 different entries. And as you can see, and this is really where we're getting now a little bit already in descriptive statistics. Descriptive statistics then slowly intersecting into inferential statistics. Because what we see, and this is just with the naked eye, you look at the numbers and how the numbers present, and then you look at incongruent and how these numbers look like, you see already there's a kind of a difference. And that difference seems to be kind of pointing towards what we have observed. It's a little harder to state the font of the color when the word means something else. So you see longer reaction times.
That's the time.
That's time. Yes, it's seconds. Good point. I should actually state the unit. Always state the unit in your header. Good observation. So what you can do now. So this is data. What kind of data is it? Yes. What kind of variable is this? Congruent. What kind of variable is that? Does it have a meaningful zero or not? Yes. Why? Well, because time travel is, yeah. So there's no negative, right? So zero is meaningful. That is the key, right? Because you can't go back. This is where ratio distinguish itself from interval. Good. Then we have this one. What is this one?
That's the amount of people.
That is, each individual has a number. Is it ordinal or is it not ordinal? I think that's the $1 million question. So you have ordinal and you have nominal. I would tend to agree with ordinal because it follows a certain order. And if the question is like, in what order did this people come into your practice or came to see you, then yes, I would agree. But you can't make this assumption. It's a random ID. So that word becomes nominal in a way. Although it's ordinal, it's structured and ordered.
Wait, so is it ordinal or not?
It is nominal because it defines an individual, right? If you would rank them, if you would rank now congruent, for example, and you give the one who is fastest a 1 and the one who is slowest 24, then it becomes ordinal because it corresponds with the order. But right now it's just randomly. Exactly. That's when the category becomes an order. Yes.
Can you explain why it's ratio? What's the meaningful zero?
Of time. You mean the meaningful zero of time? The meaningful zero of time of congruent. So it's reaction time, right?
Okay.
So the meaningful zero is that there's no zero. You cannot say a word in 0 seconds. That is kind of where we're coming from. So it is the same with the cookies, right? The cookie jar, if it's empty, this is 0. It has a very meaningful 0. And the same with reaction time. If the reaction time would be 0, that is very meaningful, but it cannot be negative.
Oh, so meaningful difference, it can't be negative? Oh, okay.
Yeah, so meaningful 0, the only positive. Yes, actually, yeah. Good. Any other questions? To be 100% transparent, the distinction between interval and ratio is something that is very peculiar for this class. There are other textbooks that you will see where this distinction is not being made. So ratio and the interval, it's a very peculiar distinction. Good. Okay. So now let's go back. So this is now our first data set. And hypothetically, you could make your first, I guess, from high school, you all know what an average is, right? Can somebody remember? Kind of, you sum up all the entries, you divide them by the number of entries. Just average. You can do this in Excel much easier by typing equal sign average B2 to B25, gives you an average. So this would be characterizing congruent, right? So that would be, yeah. So actually I did it down here already. So this is the average from B2 to B25. This is incongruent. So when you just look at these averages, you basically see already that incongruent was higher. So it required more reaction time, right?
So the average is a those number.
Yeah.
So you add them all and divide it by the number.
Exactly. Exactly. Or use the average function. But you're not supposed to use the average function before the midterms.
Oh.
Yeah. So we're going to do those calculations. We're going to do calculation of averages, calculation of standard deviation. We're going to do means. We're going to do interquartile ranges. We're going to do all of this. We're going to enjoy that, I'm sure.
What do you expect to calculate the average?
The average you can do with the average function. But if I click on it, you see it up here. I hope you can see that in green. Average, parentheses, B2 to B25. It is on cell J16 on the spreadsheet that is posted on Canvas. Okay, so let's go back to the PowerPoint presentation. So I suggest you download the spreadsheet. In the spreadsheet, you should have all of this information. I just want to quickly move on. So we talked about discrete. Yes.
So can you show how to do the average again? Because I didn't get the right.
Right equal sign.
Yeah. Then
average. Parentheses. B2 to B25. B2 colon B25. The colon. Yes. Yes. Okay. Good point. No, it doesn't matter. Not case sensitive. So you can, if you want to define a range, you're doing that by saying equal sign B2 colon to B5. That will select a certain range of data, right? If you do B2 to C5, you're selecting the entire range, and then your first entry becomes the left upper corner, Your last entry becomes the right lower corner. So it takes an entire field, an array, as we would call it. Yes. Yes, that's the Stroop test. Yes, congruent is word matches font. Incongruent is words does not match font color. The color. The color. Yes.
Sorry, what did you just do with the B2 to C6?
B2 to B5 will select just a row of numbers. B2 to C5 will basically select an array, as we call it. If it contains more several columns, it's an array. You were first. Yes. You do parentheses, yes. If you download the spreadsheet from Canvas, you will have the formula right there. Yes.
I got it.
You got it? Okay.
No, wait. Congruent matches the color of like if that's a word.
Yes, exactly. So let's go back, and unfortunately, I have here this technical glitch, but on for the incongruent. God, this is terrible. No, it's actually not that terrible. You could actually distinguish. So this white is green. This red is green. This green is red. And this brown is magenta, right?
That's incongruent, right?
This is incongruent.
Yeah.
Whereas this is, well, that's the simplest form because they're all in one color, which would be black if I wouldn't have this green problem.
Is it like congruent like for each specific one, or like in all like tableau things it's congruent, but
Each specific one. So this.
green one is congruent, all the other ones are.
Yes. So the Stroop test follows very stringent criteria, how it's being applied, and the reaction times are then basically compared and used for diagnosis of psychological conditions. Yeah.
The numbers, like all the data, that was the time it took for them to.
Correct. That's the reaction time, yes. Congruent. Correct. Yes.
This is more about like formatting the actual graph. Where would I write that in 6 seconds? Like, where would I put the
Yeah, that's the million-dollar question, right? So that's actually a very good question because it is actually proper reporting that you would always have in your variable to some extent the unit. If you would ask me, coming from the R world, I would write it with an underline SEC for second. That's how I would do it. Underline, so shift and hyphen, SEC for seconds. That's how I would code it. Reason for that is because R and Python and all these more advanced analytical tools, they don't deal well with spaces. So if you just write underlines, you just make a space and then seconds, it will fill the space with a dot, which is in practice you could get used to, but it leads to issues. Never make your variable names too long, and always fill all the spaces. Good. Any other questions? All right. So now, next. So now we're talking, so we're moving on from the Stroop test. What's the difficult? We talked about this. Okay, so a ratio is like interval, but has a meaningful 0 point, which is the lack of cookies. Ordinal, that's the cookie example. Then we have quantifications. So you have continuous variables. You can also call them scale variables. So just that you're aware. So there are synonyms for all kinds of words. And I know this is misleading, but unfortunately that's how it is. And scale variables or continuous variable are to be used synonymously. And you have ratio and interval variables, and you can, and now it's getting a little confusing for now, but we will do an example where it gets a little clearer. So nominal variables are always discrete. So they always have predefined criteria. You can't do anything else with that. Ordinal variables are always discrete. There is no deviation from that. Well, hypothetically, you could take ordinal, and you may have done that in high school. if you have a range for that ordinal variable or the nominal variable, and it defines a range of data, you can take the midpoint of that range and define that and try to squeeze it into becoming continuous. Forget this, we're not doing this. This is not being done in some rare occasions, but not by default. Interval variables are sometimes discrete. Why are they discrete? If I study fetuses, for example, that is a certain range of months. A fetus can be a fetus. And this is an ordinal kind of variable. And essentially, this can be treated as a discrete variable. In most cases, however, it's continuous. A ratio variable is very seldom discrete, but almost always continuous. So there's a little bit of an interplay. Also of note, and now it's getting really complicated, because these continuous variables, you can discretize. You can basically transform them into discrete variables by just defining ranges. So you say you have age from 0 to 100, you can bulk them into age groups, and you have transformed them into a discrete variable. Yeah.
That's the interval. That's ratio.
Yes, so you would basically create an ordinal variable, which is your age group from 0 to 10, from 10 to from 11 to 20, and then you basically create consecutively increasing age groups, and you assign this to each individual. So you discretized and you transformed a continuous variable in a categorical variable. A little complicated, I know, but it's we'll do it. Hold on. Yes. And well, it is, because you have an individual in a group, right? If you create your age groups, I would have the age group in which you're in, and then I'm the outlier. So it basically you assign all individuals into age groups, and you only look at that variable. If you don't know the raw data, the input data, you will never be able to get back to this continuous variable. So it's literally always discrete and never continuous. And you don't have the actual coin, the actual value for each individual. Yes. That means that it's predefined in categories. Yes. And you can't go back. Yeah. Yes.
An example of an interval that's continuous is the temperature example, or not?
Could be one, yeah.
What's another example of interval that's continuous?
Well, we had the fetuses, we had...
Isn't that discrete, you said?
Well, an interval is a continuous variable, right? So you have a certain temperature, but if you only have a certain range, like then it kind of becomes...
Okay, you limit it. And then it
yes,
becomes
yes, exactly. So then it's basically you are in that age group. So an age group for fetus where you have like months 1 to 6, for example, and you're only interested in that age group for whatever ultrasound reason or whatsoever, you do ultrasound diagnostic, then this is literally a discrete variable, although it's by its nature actually continuous variable.
Okay.
Yeah. I know it's a little bit challenging, but it will get clearer. So to talk about your question concerning discrete versus continuous, I was doing a little exercise here. So we have here the continuous data of the Stroop test. And we want to discretize that now. We want to discretize that now in a nominal variable. And we're going to do this by, okay, we can, first of all, we can rank them within our data set, right? So if we say, okay, this is concurrent only, that was the slowest, that was the fastest, we can order them from 1 to 24. This is an ordinal variable. That's the ranking. You're slow, you're fast, you're fast, you're slow. So now you have the categorical variable that could hypothetically, so we talk about age groups, right? If I assign every individual to a certain group, and you're between 10 and 15, you're going to come in that group. You're 15 to 20, you come in that group. You're 20 to 25, you come in that group. Then I define and transform the continuous variable of age into a categorical variable age group, which is ordinal in nature. But essentially, I would treat it more as a nominal variable. Depends then, right? So now we are interested in a simpler example, because defining in groups we're going to do with the frequency tables, and you're not going to like this exercise. It's a little bit more laborious. So to keep it simple, I defined here a categorical variable. We're only capturing those that were faster than 15 seconds. And this essentially can easily be done because you know exactly, okay, so I sorted, you can sort data, right? So if you just define the entire data set here and you go on data, just disappear.
You highlight the whole set? You're highlighting the whole set?
Yep, you highlight the entire thing. You go on sort. You can sort it by the subject ID. Subject ID. Subject ID. You basically rank it. So that's the initial form. So this is how we had it. This is how we had it on the preceding spreadsheet. This here is ranked as per the continuous variable congruent. So that's the slowest individual, and that's the fastest individual. So now, since we know this is ordered by reaction time, and you want to classify into slower than 50 seconds or faster than 15 seconds, you can define here categorical variable where everybody who's faster gets a 1, and everybody who's slower gets a 0. That's one way how to define a categorical variable based on the continuous variable. You can hypothetically also call this slow, fast, 0, 1, same thing. It's a special form of a categorical variable which is called a binary variable. So because it only has 2 possible outcomes, 0 or 1, binary. So we have here categorical variable smaller than 15 seconds. And this is where I want to talk a little bit about Excel. And this is a little bit of an interesting formula. So we have here on F2, we have the value of 15. This is our distinguishing factor. So we want to know everybody who, yes?
Sorry, so about the sorting, can you show again how to do it? Because on my computer, I don't know, this isn't.
Just let's do it together. Okay, so we're sorting, you select A2 to A26, you go on sort.
Yeah.
You go on column congruent. Yeah, so you can select here what you want to sort it by. You go on sort on values, yes, largest to smallest, which you can change now to smallest to largest, and then you go on OK. With Control C, like Zebra, you go backwards and you can restore it to the initial settings. But you can play around with sorting. This is usually quite reliable.
Go back to original.
Command and C, like Zebra. Okay. So what I want to show you here is something which is called an if-else function, because you can, and remember this when it comes to the spreadsheets, because you're going to find the functions here. Whenever you may need them down the road, you find those functions in the spreadsheet. With if-else, with that function, you basically have Excel look at a certain value, which is this one, B3, and compare it with the operator smaller sign to a certain criterion, which is F2, which is the 15. The comma indicates now, so this is the criterion. The comma indicates that this will be the outcome if this criterion was met. So if it's smaller than 15, it will give you a 1. The comma indicates then this is the outcome 1 when the criterion applies. When the criterion does not apply, then it's else, and then you get a 0. And the beauty of that is that you can complete this row super easy, and you can do this with 1 click. A little catch on that, you remember how we parallel shifted in Excel. So when we are when we're taking out here this so if we do this now, all becomes 0. You see this? The reason for that is if you propagate a formula in the way we did last time, it will propagate each part of that. So the B11, so this was B2 or B3 here on D3. So if you're going down, this becomes B11, but the problem is this criterion, which meant to refer to this here, is now F10. So it rolled down as well. To avoid that from happening, you can go and lock the cell. And you have 2 components. You have the F, and this stands for the columns. And you have the numerical value, which stands for the row. So you can lock the column and the row independently. And you do that with the $sign. So you make a $F, $2, that will lock your criterion 15 seconds in. And now you can just go again on that cell and complete it on the end. It makes the distinction. Super useful function, trust me.
What will be the function again?
It's if else. If it's this is pretty much the same in all programming languages or statistical software. So if parentheses, first the criterion, then the criterion applies, what do you want the outcome to be, and then 0. You can change it, and you can make this different. You can say if B2 smaller than B3 is smaller than $F $2 comma slow, not fast, those were the first ones, comma slow, it will do the same thing, just labeling it different. So now it's not 0 and 1, now it's slow and fast. That's pretty useful function. Trust me. You were first. Sorry. You, yes.
Can you explain again the part about why you have to lock it?
Because, yeah. So if you don't lock it, this will happen. And the locking is important because we will do this later quite frequent. So this will come back. So, okay, so now I took the $signs out. Now it's not locked. So now I move this all the way down, that's all slow. Because it's else. It's not if the criterion applied, it's else now. So you essentially, you have moved this now away and your criterion is now compared to this cell, which is not a cell. It went down with the formula. If you lock it, then it will keep F2 with $F2. If you
click on the cell and you do dollar.
You do $F $2. So this is our F2, that's the criterion. And now the beauty of that again is, if you want to change the criterion, you can change the criterion here to 19. It will automatically change the entire row. Yeah? With the $sign before the column and the $sign before the row. So alpha, the letter is essentially the column, and the number is the row. And you can lock those two.
I got it right with the whole criteria, but then when I clicked on the cell and wrote $F $2,
yeah.
then it just, that's what it wrote. So like, how do I lock it? Do I click
well, you do if.
Yeah.
B3, which is the congruent entry, is smaller than $F, $2, then, and this is when the criterion applies. So you have here logical test. The logical test is this smaller than this? If it is, value if true, then say fast. If not, or anything else, then do slow.
Can you just write 15 or no?
You have to, well, you could write 15, good point. You could manually do it in, but the idea, what I also wanted to show you is, so I do here fast, now I do here slow.
The commas between all of
Comma, fast, comma, slow, yeah. So now it does that, and the
that
reason,
locks it? That locks it.
that locks it in. And now you can propagate it all the way down. The reason why I'm doing what I'm doing and I don't write 15 is because I want to, so there's a difference between hard coding and soft coding. Hard coding is writing in your formula 15 and there you go, fine, works, perfect. I advise against that, and I advise my graduate students that learning programming from me, very, very much against that, because when you hard code, you cannot change it anymore. If you soft code it, you're defining that criterion one time here, and you can change it as easy. So if I want to change it now to 11, I can do that, and the entire row changes. And it's the same when you're programming R, and maybe we're going to come today to some R. It's the same concept. If you soft code it, that's one point on line 2 in your code, and you say criterion equals 11, you can just change it at one spot. If you have it in every row again, or every time this criterion is being applied again, this will essentially lead for you to have to change it everywhere. And an average code for a paper is somewhere between 3,000 to 4,000 lines. You don't want to change it everywhere, trust me. Yep. All right. So that's the idea, hard coding, soft coding. But something, yeah, quite advanced. Okay, what you also will need to do and what you can do, that's the beauty of it. And we're getting to that next class, not Monday, Wednesday. Actually, Labor Day, there's no class. So you can count it. You can count the number of entrants where it was smaller than 11 seconds. And you can do that by essentially using the sum function. It's one way to do it. We will discuss different ways. This is the simplest way. So this is a so-called frequency table because you're counting the frequency of the occurrence of a certain value. Frequency table. We will do that on Wednesday next week. We're going to learn a bit about volcanoes. Spoiler alert. Okay, good. Any questions about this? Simple, right? Okay. Mixed reviews. Okay, so this play around with the spreadsheet, play around with the formula. It's a very useful. The functions I put in there, I put everything. I put a lot of thought in this. So like, have a close look at the functions and whatever I'm trying to present to you. Good. So now we're back to variables and research. Any last concluding questions on any of what we discussed now? Because if not, then let's move on. So essentially you have in research, you have 3 most important variables that are finding their way into your research. You have, and I'm deviating from the order, a dependent variable. That's your outcome. That's what you're interested in. That's actually that you mentioned, that's what you measure. And that is the reaction time on the Stroop test, right? That's all that really counts. The independent variable, and that's the first entry, that is the variable that you essentially, I hate the term manipulation, but I see where they're going with this, but you're using that to categorize it. So this is the categorization. Is it incongruent or congruent? That is your independent variable. Outcome variable, dependent. Defining variable of categorization, that's your independent variable. And then you have a third variable. And that variable is usually a little harder to explain. Because if you have, so the Stroop test is being conducted to diagnose some certain psychological conditions. Or it can be used in diagnosis of some certain strokes to find the area in the brain that is affected by this stroke. So a stroke is basically a clot or a bleeding in a certain predefined area of the brain. And depending on the size, it has different effects, which can go in the worst case up until death. So there are some smaller strokes that essentially can lead to problems with distinguishing between colors. So Stroop test goes in that direction, that it diagnoses and helps the diagnosis of such conditions. Good. This is your confounder, because this is what you're trying to diagnose essentially. So you know, you're measuring your outcome, you measure the reaction time, you know whether it was congruent or incongruent. Those that were not able to distinguish at all between the color, those that needed particularly long, or those that were just like somewhat normal reaction time or differences in reaction time, they are healthy. So this is your confounding variable in the Stroop test. So you have exposure, the categories, the definitions, the manipulations. That's your independent variable. Pathway to your outcome, which is your dependent variable. Independent variable determines dependent variable. And then you have on that pathway between those two, you have a third variable, and that's your confounder. Yeah, I see your question.
I don't understand the confounding variable.
So the confounding variable is a variable that affects that pathway. And we will talk about it a little bit more when it comes to research design. Let's assume the outcome to be grades on an exam. And you basically you build a very easy question, a very easy exam, and a very hard exam. So there are two groups. You wanna test out. It's like, so my first test before I started using test banks, I designed myself. After a couple of pilot projects, I gave up on that, and then I used test banks. So for different reasons. So essentially, you have a hard test and easy test, and you have a group of students that completes both of those. You would expect the outcome to associate with the hardness of the test. How difficult is the test, right? So now the confounder in between is, what if I give the easy test only to the really good students and the hard test to the really not so well performing students? That's the confounder. Performance of the students, interest of the students.
You would do that purposely, like.
Well, I'm not doing it. Yes. If this is a research experiment, you can do that. Yeah.
That's another variable that's like.
It's a third variable that has some effect and that changes the pathway from the independent variable to the dependent variable. Right? Yes.
So in our example, like the number of seconds it takes to recognize, if someone got it like 1 second or someone got it like 100 seconds, those would both be the same variables.
No, if somebody makes it in 1 or 100, that essentially is your dependent variable. So what you measure is your dependent variable. Whether it was congruent or incongruent, that's your independent variable. And the reason why that individual was fast or slow, that's your confounder.
Oh, okay.
Yeah. Yes.
Isn't the independent variable the variable, I mean, not dependent variable, the variable that you're manipulating, or like you're changing? But yours is the independent variable, is the variable that you're manipulating.
Yes.
Isn't it, I thought it was the opposite.
Okay.
Independent variable is the variable that like you're manipulating and that you're changing.
Based on what did you think that was?
Like, I'm confused between your definition between independent and variable.
Well, it's not my definition. So the dependent variable is the measured variable. So this is your outcome.
Oh, like at the end.
This is at the end, this is your reaction time. This is your reaction time, and the independent variable is the definition, the categorization, congruent, incongruent. Yeah? Yes.
For the spiritual test, what was the confounding term?
There would be the pathological condition, for example, that causes differences between congruent and incongruent.
But
So if somebody, yep, no,
the
please.
change of color would be the independent variable because that's what you're.
Yes, whether it's congruent or incongruent, that would be the independent, yes. The independent variable. Because then you categorize, right? So you take that sheet of paper with those four numbers, with those four words on that, you give it to the patient. What's the name? What's the color of the font? So it's you defining your independent variable. Is this now congruent? Are we measuring congruent or are we measuring incongruent? That's when it becomes the independent variable, the definition. All right. Good. So this distinction is super important because I will refer to dependent, independent, and confounders quite frequently. Good. So now when we talk about the dependent variable, we also need to talk about reliability and validity. Reliability is when you measure something one day and you measure it again the next day and it's still the same, like the height. Well, given that we all have reached an age where we're not growing anymore, it's like height should be considerably consistent, right? So it shouldn't change from today to tomorrow. Well, there's a confounder in there, and the confounder is the quality of the person measuring it, or the quality of the measurement tool. But that's a whole different conversation. Good. A valid measure is one that measures what it was intended to measure. A measuring tape should accurately measure height. No, well, now we're getting action there, right? So that's validity of the measurement. If a measuring tape should accurately measure height, this would be reliable and valid variable measurement, dependent variable. Makes sense, right? Validity and reliability. So what is not, so yeah, Rorschach ink blot test, and there we go again to psychology. Also for personality disorders, there are tests, or visual and audiovisual tests. And the Rorschach ink blot is only visual. It's essentially a test that is used in psychology. I'm not sure how frequent at this point, as said, not a psychologist, but it has been quite debated because it was neither reliable or valid. Who of you knows what the Rorschach ink blot test is? Yep.
I think so. Is it when they like show you the paper and it's just a blob and say, what do you see?
No, it's let's have a look. I don't think so. Let me show you what Dr. Google says. So it has a very characteristic shape. Rorschach ink blot test. Here we go. So it basically it's a very characteristic figure and shape that is being shown to patients and adolescents for the diagnosis of various conditions. So you get this shape in front of you, and then you're meant to interpret what it is, what you interpret in this.
Different shapes, right?
Yes, I think they're different shapes, yeah. Yeah. So whatever you see in there is then to some extent used to interpret. This is
Is it actually accurate?
that is the problem, because it has been debated in terms of reliability and validity, and this is what this means to reflect, because reliable would mean that you use it today with your patient, and then you use it again in 2 weeks, and the interpretation would be the same. That has been debated. Valid is like, if I look at that and I interpret it, like, does that really say whether I have personality disorder? It's like, I don't know. I'm a data and numbers guy, not my kind of metric. But doesn't mean it's bad. It's like, I'm by no means qualified to say yes or no. So, but this is an example where reliability and validity has been debated. So, okay. All right, Rorschach input test. Hypothesis testing. Any questions to Rorschach input, reliability, validity? I think it's kind of, you just got to repeat it, but I think it's quite a graspable concept. Hypothesis testing is the process of drawing conclusions about whether a relation between variables is supported or not supported by the evidence. If I say that all people in New York are rude, I go out on the street and I find 10 nice people, is that sufficient evidence that they're not all rude? Right? Those of you who live in New York, New Yorkers are not rude. May have not good luck by meeting some that are not particularly nice, but overall they're not rude. So essentially, it is a hypothesis that you put forward. It's a statement. And then what you're basically trying is to find evidence and gather evidence and analyze this in some shape or form to either accept that your hypothesis is true or to reject that your hypothesis is not true. So it is a very typical statistic-based process, and we're talking essentially about null hypothesis and alternative hypothesis. So when you have research where you're comparing two groups, your null hypothesis is that there's null effect, there's no effect. This is your hypothesis with which you start. You say there's no effect between those two populations. And you are basically, you're creating statistics in a way to find out whether you are accepting this null hypothesis or you're rejecting it and accept the null, the alternative hypothesis. So null hypothesis, alternative hypothesis. And this is hypothesis testing, which essentially is, that's what this whole class and pretty much everything in statistics is about. It's about null hypothesis and whether you reject or you accept them. And to do that, you need to have variables. You need to have a definition of your variable, which was in the case of our Stroop test again, it was congruent, incongruent. This was your definition. This was your independent variable. And then you have a certain framework in which you measure this, which is the test per se. This needs to be standardized, and you need to have a way to operationalize this process to collect standardized and analyzable data. So basically you have, in this context, you're framing a hypothesis in terms of independent and dependent variable that allows you to answer and test a hypothesis that you have defined before you designed your experiment. Any questions? It makes sense, right? It's like you're designing a study to collect data that allows you to answer a certain question. I see some skeptical looks here. All right. So operationalized variables, and this comes back to, okay, with the Stroop test, we meant to diagnose a pathological condition in the brain. Now we want to find out whether pet owners are happier. So what's your dependent variable? Your dependent variable is here the level of happiness of your respondents, and your independent variable is, does the person actually have a pet or not? Okay. Cigarette smokers are weak people who have no willpower. Dependent variable is the level of cigarette smoking. So how many packs does this individual smoke? Independent variable is the amount of willpower. How caring are people, and they have this example for another time. So people that use social media excessively don't care about other people, although they say they do on social media. So dependent variable is how caring people are. Independent variable is social media use. This is what you need to take into account when you operationalize variables to essentially answer your research question. You have a research question, which is usually a narrative, and you will see this in practice lab. There's a practice quiz. You will have a couple of examples, and it will ask you to operationalize variables that will allow for you to answer the research question. It's usually something where you have a certain narrative of that defines a research question, and you will need to bring it in shape or form to define what will be your dependent variable, what will be your independent variable. So I'm flagging this because through all, how many chapters, 18 chapters, you will have to understand this definition. So that is super important. Operationalization of variables. Good, so this is hypothesis testing. This is the comparison of groups, of predefined groups. But you have some different form of analysis that you can do, which is here a correlational study. A correlational study is a study where you basically, okay, correlation is where you test an association between two variables. You associate two variables, healthy behavior, with the use of wellness programs. If somebody is in a wellness program, it's more likely that that individual does not smoke anymore, does more exercise, does some meditation, and kind of is more embracing healthy behavior. So now, in this context, it's important, these are correlational studies, but then you have to test for this association and confirm them in a real-life setting. You can only do that by testing them in experimental studies. Because we talked about independent, dependent variables and confounders in between. The only way to get confounders out of the equation is with random assignment. So let's go back to, this is unfortunately a little bit complicated to do, and you cannot answer every research question with the minimized confounding through random assignment, because like pet ownership, pet owners are happier people. You can't operationalize the variable pet ownership by taking people their pets away and giving to other people who don't want their pets, right? So it's complicated. Same with cigarette smoking. Like you can't assign a group of people to start smoking. So it's very complicated. But in a perfect world, you would randomly assign between the groups, because by that you remove confounders for the reason, if you have a random assignment to groups where you have employees get into a wellness program and employees who will not get into a wellness program, and then you measure the dependent variable of health behavior, if you have them self-select whether they want to be in that program or not, the self-selection is the confounder, because this self-selection is caused by an interest in healthy behavior, which will then basically torpedo your own outcome. So you need to randomly assign them into these groups. You need to have equal willingness to change behavior in both groups. And this being said, okay, give me one more minute. So there you basically have a between groups design and a within groups design, where between groups design is randomized to that group versus randomized to that group. And you compare these two groups. Within groups design is you have one group of people and you follow them over time, then you step change them, and then you measure the change. That is within groups design. And then lastly, I'm commenting here on data ethics. Now let's talk about this next time. Okay, have a nice evening. Thank you. This is not to be completed. This is at your own. If you don't want to do it at all, don't do it at all. I recommend you do it, but it's at your own. I'm not even seeing whether you took it or not. Yes, you will get the answer at the end of completing the course. No homework yet, no.
Sorry,
yes.
Because I messed up my schedule. I'm Emily Dinner.
Oh, okay.
Thank you so much.
Sure. Hi.
It's okay if I ask a question.
Yes. Wait, hold on. Yes.
Okay, I was a little bit confused about what operationalized variables are.
Yeah. So an operationalized variable is a variable where you had a research question and you're collecting some certain data. You're defining what is my dependent variable, what is my independent variable. Pet ownership causes happiness, or pet owners are happier. You need a group of pet owners and a group of non-pet owners, and then you measure as the dependent variable, you measure the happiness. This is operationalization for research. So you're taking data that you have available or that you can collect in a group of people, and then you define your independent and you define your dependent, or you think of which dependent variable could characterize and address your research question, and that is the operationalization.
Operationalization is testing.
It is finding ways to test the data that you have at your disposition to answer your research question.
So finding a way to test the level of happiness in the pet ownership example.
No, because that would be only the dependent variable. It's really the definition. You have a group of people, you want to know how happy they are, and whether pet owners are happier than non-pet owners. So, okay, so now you measure from each of these individuals, you measure the happiness. That's your dependent variable. That's what you're interested in. That's your research question. And now you want to find out whether pet owners are happier. And then you ask them, okay, are you a pet owner? And then you have the pet ownership as your independent variable. And then you measure pet owners versus non-pet owners. Which one is happier? And that's it. That's the Stroop test, right? Reaction time, congruent, non-congruent.
The whole data is operational. Got it. Okay, thank you.
The data definition is the operationalization.
Thank you so much.
We'll get easier by the end of the
Okay, so I just joined this class, this is my first class.
Okay.
But like the class that was on Monday, I was joining into it while it started. So it's like work and absent, but I was like joining into it and I was like in this time slot, but then I like, switched to this time. The one that was just now.
Okay.
So it's like a whole confusion, but I wasn't actually absent. I was just fixing my schedule.
Okay. So yes. So I have a certain leniency with absence or non-absence. It's fine. Just remind me we had this conversation. In case you're missing more often, and we gotta have this conversation, then remind me of this conversation.
Okay.
But it's
Thank you so
you're
much.
gonna be fine.
Great class.
Thank you. Welcome back. All right, welcome back. What? Oh, goodness. Good evening. How are you? I hope you had time to digest the class a bit from Monday. Oh, I got to change here. Any question to what we discussed in last class?